All right, get ready for a dive into one of the weirdest, most brilliant ideas in all of physics. We're talking about quantum tunneling. It's this wild phenomenon where the tiny particles that make up our universe do something that, according to all the rules we see every day, should be totally, completely impossible. And look, that's not just some poetic way of putting it. It is the literal truth of the quantum world. We're talking about a realm that runs on rules so bizarre, they seriously sound like they were ripped straight out of a sci-fi movie. Okay, so here's where things get really weird. In our world, the world we see, things just make sense, right? If you throw a ball at a solid wall, what happens? It bounces back. Duh. It can't go through it unless it has enough energy to go over it. Simple. But down in the quantum world, that exact same particle, it hits that same barrier, and instead of bouncing off, there's a chance, a real, actual, measurable probability that it will just pop out on the other side without ever having the energy to get over it in the first place. Okay, so let's really dig into this because it feels like it just shatters the basic rules of reality that we all live by every single day. I mean, just think about it for a second. Nothing in our day-to-day lives prepares us for an idea like this. You can't walk through a wall. I can't walk through a wall. A car can't just decide to drive through a mountain instead of over it. For us, a solid barrier is, well, it's absolute. It's a fundamental rule of our big, macroscopic world. So that's the million-dollar question, right? If everything we see and feel tells us this is impossible, what in the world is going on down at that tiny subatomic level that just completely flips the script? Well, to get that answer, we have to stop thinking about a particle as just a tiny little marble. We need to see it as something much, much weirder. Think of it like a quantum ghost. Right, so this is the textbook definition. It's a particle passing through an energy barrier that, classically, it has no business overcoming. I love this analogy. It's like having just enough cash for a bus ticket, but somehow you end up on a first-class flight to another continent. It just completely defies the rules as we know them. So how does it do it? Well, the secret isn't some kind of magic trick, and it's not brute force. It all comes down to the fact that quantum particles aren't just little points. They're also waves. Specifically, a wave of probability. You can sort of picture it like a cloud, representing all the possible places that particle could be at any given moment. Okay, so this breaks it down step by step. First, the particle's probability wave hits the barrier. Now, most of that wave does what you'd expect. It bounces back. But, and here's the kicker, a tiny bit of that wave actually leaks into the barrier. It gets weaker and weaker as it goes, it decays, but it doesn't just disappear completely. And if that barrier is thin enough, a tiny, tiny little piece of that wave pops out on the other side. And since that wave represents where the particle is, well, now there's a non-zero probability that the particle itself is on the other side. It has literally tunneled through something that should have been impossible. And this isn't just random chaos either. Physics actually gives us the rules for this. The chances of a particle tunneling go way, way up if the barrier is thinner or if the energy of that barrier is lower. It also works much better for really light particles, like electrons. And that right there is why you and I can't just walk through walls. We are just way too massive. Our probability of tunneling is so close to zero, it might as well be zero. So I know this all might sound like some weird, abstract, cosmic quirk that doesn't really matter. But you'd be wrong, because we've actually figured out how to harness this impossible effect, and it basically powers our entire modern world. I mean, just look at this list. It's astounding. The flash memory in your phone, in your computer, that works because of quantum tunneling. Super fast electronics? Yep, that too. We have these incredible microscopes that let us literally see individual atoms, all thanks to tunneling. And it gets bigger. On a cosmic scale, the sun, our sun, is powered by quantum tunneling. It's what allows nuclear fusion to happen, lighting up our entire solar system. Just let that sink in for a second. The exact same ghostly particle behavior is the reason you can save photos on your laptop, and it's the reason we have light and heat from our sun. This isn't some fringe idea. It's absolutely fundamental to, well, to pretty much everything. All right, so let's wrap this up. Let's talk about the incredible quantum secret our entire world is built on. If there's one thing to take away from all this, it's that our reality is so much stranger and honestly, so much cooler than it looks. This solid, predictable world we walk around in, that's just the surface layer. Underneath it all, there's this wild universe of probability waves and impossible jumps where the rules we take for granted are constantly being, well, bent. And that's the thought I really want to leave you with. If the universe has this kind of fundamental rule breaking built right into its fabric, this ability to tunnel through impossible walls, what else is out there? What other laws of reality are maybe not quite as solid as we think they are, just waiting for us to find them?